Today we're continuing with our subject on data visualization and data. So we will be focusing today on understanding data, the types of data that they are, data pre-processing, that is preparation of data for analysis and visualization, and as well as discovering patterns and trends into the data, that is knowledge discovery in databases, or KDD. Alright, so let's talk about data once again. So the data is raw, unorganized facts that need to be pre-processed or processed and organized in order for a human being to make any logical sense or to understand them. Data would be like raw numbers and raw letters or strings that are recorded in a database. That could be a flat text file or a more complex relational database, or even more complex unstructured database, or a database in a form of a graph or molecular structure or some other structure that it has. So the data needs to be processed and organized for a human being to be able to make sense of the data. So the data is a set of facts and statistics that can be operated, referred, and analyzed. The metadata is a description of the data, and that's why it's called metadata, because it's data about the data. That is, it's a description of the data. Let's say, when the data file was created, what is the date and time of the creation? Who is the owner of the file? How large is the file? When was the file last accessed? And when was the file last modified? All of these things are descriptions of the data. So it shows basic information about the data, which can make it easier to search for the data and to work with specific instances of the data. So the metadata would provide a framework for the data, and it ensures that business users are better able to understand the data available within the warehouse. So the metadata is a description of the data, that is data about data. What other types of data they are? So data types would be similar to the data types in programming languages. A number, for example, an integer, or a floating point number, or a double number. That's a data type. It's of type number. It can also be a character. For example, A, uppercase A, lowercase a, B, C, D, and so on. Any of the characters that we would press onto the keyboard would be considered a character, and it is of size, if we're to store this character into the computer, it's going to be of size 8 bits. So every time we press a character on the keyboard, it takes 8 bits of memory to store this character. A string would be, so that is, a character is of a specific data type because it takes 8 bits. Now, a string is, for example, a word or a sentence. A string will be a group of characters, such as 1, 2, 3, 4, A, B, C, D, Smith, or I am happy. So that's a string. A data of a Boolean data type is just a 0 or a 1. What is a bit? A bit is a single digit that is either a 0 or a 1. It's either equal to 0 or 1. A data of type Boolean, it's going to take a single bit and it just has a flag in the memory that's either set to 0, which means true, or to 1, which means false. So Boolean is a true or false data type, pretty much a yes or no data type. So the yes or no would be expressed as a 0 and a 1. Alright, so derived data types, they could be data types of mixed kind. For example, a date and time. So date and time would be a mixed type because it contains both a string for the data, for example, 18th of May, and it also contains a time, for example, 9 o'clock. So that it contains both a letter and a number. So because of that, it's a mixed data type. There could be other data types that would be much bigger, such as a structure called student, for example. Student, we could have a data type of type student. What does that mean? Well, a student is a data structure that contains a name, an address, an age, a degree, classes he or her is taking, the location of where they live, or their picture. All of that belongs to the data structure called student. So we could have a student data type which would contain things like name, picture, address, degree. So that would be data structure, essentially. Alright, so data types. What we have just seen earlier, like the integer, character, Boolean, true, false, and so on, these are the basic data types or primitive data types. They are built in or predefined in most databases data analysis tools, and programming languages. If we're to have some complex data type, abstract data type, user-defined data type, like the student, then that's something we need to define. It doesn't come in with the system by default. Alright, so the character data type, as we mentioned, it takes 1 byte of memory space. Let's look at the data storage formats. So, what are files? As we all know, we have a hard drive on our computer, whether that's our laptop, whether that's a computer in the university computer lab, or whether that's our cell phone. Cell phone is a small computer, believe it or not. So, it has a hard drive, and onto the hard drive we can store files. Okay, so onto the computer hard drive is a disk that is organized as blocks, and in each block of memory we can store data. Usually the smallest data location is 1 byte or 8 bits. And the reason for that is so that we can easily store 1 character from the keyboard. Onto this disk we can save things like files, directories, and databases. So what is a file? A file will be an electronic list of data that is intended to perform a particular function or transaction. A database is a much larger file or collection of files that it would be stored onto the hard drive. It might be a collection because let's say we have a student's data type here. Let's go. We want to store these students' records into a database. We can have a database called student that would have columns name, picture, address, and degree. That's a table. That's 1 file. Now, if we want to have another table for the professor's name, picture, and address, and degree, then that will be a second table. And if we want to have a table of classes that the students are taking and the professors are teaching, then it will be a third table. That's why we're saying here that it's a collection or a grouping of files. So the student database would contain students, professors, and classes. And they are related to each other. They are related because a student takes particular class. So the student table is linked to the class table. A professor teaches particular class, so that the professor table is linked to the class table. So they are interrelated, and because of that, it helps for efficient retrieval, insertion, and deletion of the data, as well as organization of the data in the form of tables, views, schemas, and so on. So the files, like we said, would exist onto the hard drive. The hard drive is just a disk that is organized in blocks of memory of size 1 byte. If the file takes 1 byte, good. If it's bigger than that, it's gonna take 2, 3, or more bytes. So we need to determine how many bytes it took and where they are located on the disk blocks, because each of those memory locations would have an address. So because of that, we need to know where the blocks of this file are located and what are their addresses. So we need a pointer to the file. The pointer, it's going to hold the memory address of where the file is located. We could have a more complex structures. For example, linked list. Linked list would be, let's say we have several students enrolled into a class. We can have the first student, the second, and the third, and they are just linked with a pointer. The first one points to the second points to the third, and then we have the last one. So a linked list like this could be stored where each student is located in a different memory location that is not necessarily sequential or in order from the previous one. This is helpful in case we want to optimize the memory usage and use spaces wherever they are available instead of taking one big block of contiguous memory locations. Okay, so we have different kinds of files. We have master files, lookup files, transaction files, OJIT files, history files. So pretty much any information that we store into the computer for our notes, for our logs, for our databases, or whatever we do is stored in the form of a file, and we can organize them in folders or directories. What is a database? So the database is organized collection The database is an organized collection of structured information or data, typically stored electronically. In a computer system, the database is usually controlled by a database management system. The reason we need this is, remember all those disk blocks. Let's say we have the file that took more than 1 byte. It needs 3 or 4 bytes. So all the parts of this file are located in different memory location. We need someone to know where are all these locations of all these files and provide a pointer to where the file begins. The database management system is a special software, kind of like the operating system, that knows where are all the files that are part of this database. Where is the student table? Where's the professor table? Where's the classes table? How big are they? Also, it allows us to modify, insert, delete records, or create new tables, or even delete those tables if we want to. It allows us to have multiple databases on the same machine. It also allows 2 or 3 users to simultaneously change the records without overwriting each other or causing issue with the data integrity. So the database management system handles the databases, allows us to store, retrieve records, add and delete records, and to query the databases. That is, we want to find particular student name or student ID. Is this student currently enrolled? What classes is he or she taking? So this kind of queries would be answered by the database management system. So it will provide answers to the queries and reports. So the database can be easily accessed, managed, modified, updated, and so on. The structured query language is how we would ask the database for specific records. like specific student, specific professor, or other questions that we have. We would send a query to the database, and then that query would be answered. This query language allows us to also generate reports. How many students we have altogether in this session? How about the next session? Or where are these students primarily living, in what zip codes? What degrees is the most popular? Things like this, in sort of reports, can be generated as well by using this standard query language. As we have seen in the previous lecture, there are a number of databases types that have different structures that exist. A database can just be saved into a text file. Student 1, student 2, student 3, here's the properties or features of the students. It can be saved into a table that is given to a management system, a relational database management system, where queries can be run. This is the most popular. It can be a table of objects. There could be distributed databases. This means part of the database is here, another part is in Europe, another part is in China, and they are connected. Maybe it's a huge corporation that has offices in all these different countries, and it needs to connect its database. That will be a distributed database. We also have data warehouses that are much bigger, allow for data integration and grouping. Multidimensional databases, NoSQL databases. These are databases like the Facebook data or the Google data that they don't come into a table, but there is just a bunch of messages from people messaging their friends and sending pictures to each other. They're not in a table. Same situation with the web pages on the internet. They're not in a table. We have a bunch of pages linked together through hyperlinks. These will be NoSQL databases. These, though, the web pages, though, because they're linked through the hyperlinks, can be in the form of a graph, where we have one page represented by a circle or node, pointing to another page represented by an arrow going from the one circle to the second circle or node into the graph. In that case, we have a graph of all the pages on the World Wide Web, where each page is one circle and each link from each page to all the other pages is represented as an arrow. Same situation with the Facebook data. One friend points to another friend because these two are friends. So we can have all the people on the Facebook connected to their friends through arrows, and that will be another graph there. Right. Multidimensional database will be something that includes, for example, time. What happened today, what happened in yesterday, or what will happen tomorrow to the database. This could be like weather forecasting data that was recorded through time, and it has another dimension or depth to it. Normally the table will be 2-dimensional, but if the time is there, then it becomes 3-dimensional. As we mentioned earlier, NoSQL data will be unstructured databases, collections of documents such as the pages on the World Wide Web or the Facebook data friends. There are certain database management systems that allows us to work with unstructured data like this and send queries similar to the SQL queries we would send normally to relational databases such as MongoDB, Cassandra. These are database management systems for non-SQL data. Other ones would be the graph databases, as we already mentioned. We have to decide on what storage format to use. So, if we're to have a database, we need to decide on the data storage format. Do we want to have a relational database in the form of a table? Do we want to have a graph? What data types would be in there? Integers, strings, or some special abstract data type that we would define, such as the student structure. What would be the data types? So this is something that we need to decide as a data professional. Data analyst. We can decide this by using the type of the system that it will be applied to, so application system, by examining the existing storage formats or what are the customer requirements. The data warehouse would be a single, complete, and consistent store of data that is obtained from a variety of sources and made available to the end users. As we mentioned earlier, the data warehouse allows us to integrate data together. So let's say two companies merged. One company bought the other one. Now they have completely different databases with different customers, but they want to merge them and integrate them. So the data warehouse would allow for such a data integration. In support of the management decision-making process. So we would have a variety of data sources. They could be different databases. Text database, XML database, relational database. We would extract, transform, and load them into the data warehouse. So as we mentioned, if two companies are to merge, let's say these are retail companies, they have supply chain management, billing, electronic processes, all of those databases can be merged and integrated into the data warehouse in order to generate visualizations, reporting, and business intelligence. So what is business intelligence? So the business intelligence is the information that's going to help the decision-making process of the business. That is, Why do we collect all this data? What are we hoping to discover in there that's going to help us to accomplish our goal? If we are a financial institution, our goal might be to make profits, or retail stores. If we are a medical institution, our goal could be to heal patients and create new pharmaceuticals or drugs. If we are an educational institution, our goal might be how to create a better learning experience and a higher quality education for the students and a more happy and comfortable campus, for example. So, business intelligence is about how to accomplish our goals. Data mining would be the data analysis that we perform on the data in order to help accomplish those goals. So, the data mining would discover new, non-obvious, and valuable information from large collections of data. This process is also called knowledge discovery in databases, because we will be analyzing and mining the data in order to find useful, actionable information or knowledge that will help us to accomplish our goals. This is called a knowledge discovery into the database. Knowledge discovery in databases, or KDD. That's a whole process. Now it starts with determining what data we will use in preparing the data. So there needs to be some pre-processing done to the data in order to preparing for mining or for analysis. What pre-processing needs to be done? Well, if we are going to use some machine learning tool like a neural network or a rule extraction or a decision tree or a clustering and unsupervised learning, this method expects data to be in certain format. Alright, there needs to be rows, columns, there need to be a class attribute that says yes or no, positive, negative, or a class healthy or cancerous, or a class profitable and non profitable, or a class happy and unhappy, and all the other 7 emotions in between. It expects data to be in certain format. So pre-processing, we have to fit the data into that format. So certain cleaning of the data needs to be done. Removing of missing values. Let's say the data mining or machine learning tool is going to break and crash if there were a bunch of values that were empty equal to null. Well, these need to be removed in order to make it work. So null value removal or missing value removal or missing value imputation. What should be the value that is missing? We might be able to determine that and fill it in instead of removing it and deleting the records. Cleaning missing value imputation and placing the data into the proper format is part of the data pre-processing. After that, we can select a data mining task that we can do. For example, certain machine learning algorithm. Once the data is ready, we can do those analysis. And finally, evaluation presentation. Is this good? What we just discovered? Is this useful? Present user with essence of the discovered knowledge and a good visualization of the discovered knowledge. So data visualization falls into the end of this knowledge discovery and databases process. So that is what we have today for our data types, data types, databases, and knowledge discovery in databases.